example 2.3.4. Find the apparent power for example 2.3.3. Also determine the power factor. From 2.3.3, we know that P is equal to 1953.12 watts, and we know that Q is equal to 1953.12 var. We're asked to find S, which we know that S has a magnitude and a angle associated with it. And then we're also asked to determine the power factor. So the solution to this is to use the power triangle. We know that the base of the power triangle, the real portion, is represented by power, 1953.12. Watts. And so we've got the real, sometimes called the active power, sometimes called the average power, on the real axis there. And then since this is positive var, power triangle is in the first quadrant of the complex plane. That means this arrow is pointing up, not down. And that's also 1953.12. And that's in var, so that's equal to Q, imaginary or reactive power, and P is real or active power. S is the vector sum of those two quantities right there. And so we can see that S from this triangle is equal to P plus or minus JQ. I use plus or minus because Q can be negative sometimes. So S is going to be equal to 1953.12 plus J 1953.12. So that's rectangular form. Typically S will be given in its polar form, and so if we want to know what the polar form is, that's going to be the magnitude of S is given by the square root of 1953.12 squared plus 1953.12 squared, right? To determine the hypotenuse of a right triangle, I take the square of the sum of the two sides, and that's going to give me a value of 2,762.213. And then the angle, that's this angle right here, phi sub s, is going to be equal to the inverse tangent of 1953.12 over 1953.12. So the inverse tangent of 1 equals 45 degrees. Therefore, we say that the apparent power in the circuit is 2,762.213 at an angle of 45 degrees volt-amps. The power factor can be determined a variety of ways. By definition, the power factor is the ratio of real power in a circuit to apparent power in a circuit. So we can just do simple division, take 1953.12, the base of the triangle, and divide it by 2,762.213, the hypotenuse of the power triangle, and we get an answer of 0.707. Since it's a division of watts over volt-amps, watts and volt-amps, although they have different names, they really represent the same thing, so those units cancel, and we get 0.707. Pretty commonly, you'll see that power factor is, some textbooks define it as the cosine of the angle between the real power and the apparent power. That's a convenient way to calculate it, but I don't think that's a very good definition. But anyway, if you use that, it's cosine of 45 degrees. That's equal to 0.707, right? And we know that cosine is adjacent over hypotenuse, so those relationships are just coming from the SOHCAHTOA rule. So anyway, power factor is 0.707, and apparent power is 2,762.2 at an angle of 45 degrees volt-amps.